This looks like a normal hibiscus flower. You have seen it many times in gardens, temples, and roadsides. Most of the time, we walk past flowers without really looking at them. Our eyes see color, but they miss the structure. But today, we are going to see something that most people never see. Hello everyone, welcome back to my channel. In today's video, we are going to explore the hibiscus flower and all its parts, not just with the eyes but under the microscope at 50x magnification. Everything you will see today is real. No animation, no editing tricks. If you're watching on a mobile phone, I recommend watching in full screen. Let's slow down and observe. This hibiscus flower is commonly found in tropical regions and is used in medicine, hair care, and even tea in some cultures. But today, we are not focusing on its uses, we are focusing on its structure. At first glance, the flower looks simple, but it is actually a complete reproductive system. Broadly, this flower has petals, sepals, the male part called the stamen, and the female part called the pistil. Each part has a specific role. Nothing here is accidental. Nature doesn't rush and it doesn't waste. Now let's separate these parts one by one and see what secrets they hold. Let's begin with the petals. Petals are the colorful part of the flower. Their main job is to attract insects like bees and butterflies. If you notice closely, each petal is slightly different in shape. The edges are not perfectly smooth. You can already see fine veins running through them. These veins act like highways for nutrients and water. When you touch the petal, it feels soft and delicate. But don't be fooled by its softness. This petal is stronger than it looks. Now let's take one petal and place it on a glass slide. This is hibiscus petal under magnification. Take a moment and let your eyes adjust. What looks smooth before is actually full of texture. You can see tiny cells arranged like tiles. You can see uneven surfaces and fine structures. What looks flat to our eyes is actually three-dimensional. Each of these cells once grew from a single point. Light reflects differently from each surface, and this is what gives petals their glow. Nature doesn't use paint, it uses structure. Imagine how small these details really are. Now let's move to the male part of the flower, the stamen. The stamen is usually the most noticeable part of the hibiscus. It extends outwards so insects can easily touch it. The stamen has two parts, the filament and the anther at the tip. The yellow color of the anther acts as a visual signal for pollinators. Even a gentle breeze can shake pollen loose. This design increases the chance of reproduction. Let's take a closer look. This is the anther under the microscope. And now look at the pollen grains. Each tiny dot you see is a pollen grain. Each pollen grain carries genetic information. Some pollen grains look round, some look textured, some even look spiky. These shapes are not random. They help pollens stick to the insects and reach the female part of the flower. Only a few pollen grains succeed, yet the flower produces thousands. This increases survival chances. Even damaged pollen grains show incredible structure. This is how plants reproduce silently, beautifully, and without moving an inch. Now let's look at the filament. The filament may look simple, but it has very important job. It must hold the anther upright. At the same time, it must be flexible. Under magnification, you can see fibrous structures inside it. This balance of strength and flexibility is fascinating. Nature designs for efficiency. Now we come to the female part of the flower, the pistil. At the very top is the stigma. The stigma is positioned exactly where insects usually land. Its surface is not smooth for a reason. Sticky does not mean wet. It's a biological stickiness. Its only job is to catch pollen grains. Let's see how this looks under the microscope. This is the stigma under the microscope. Notice how uneven the surface. You may see tiny knob-like or hair-like structures. More surface area means better pollen capture. Once pollen sticks here, it begins its journey down the style. This eventually leads to fertilization and seed information. This is where life begins for the next generation. All of this happens quietly, without sound or movement. So, the next time you see a hibiscus flower in your garden, remember this hidden microscopic world inside it. A flower is not just beautiful, it is engineered for life. This entire system works without a brain or nervous system. Yet it is more organized than many machines human build. Thank you for slowing down and observing with me. If you enjoyed this journey from the garden to the microscope, please like the video. Subscribe to the channel and comment below which part amazed you the most.